I would suggest that you pause the video and try this warm up. Okay, so using the arrow notation, we should have gotten that as x approaches -3 from the right, f of x approaches -infinity. As x approaches 2 from the left, f of x approaches positive infinity. And as x approaches positive infinity, f of x approaches 0. We are going to continue with section 3.5 today, rational functions and their graphs. Today, we are actually going to start graphing rational functions. So let's talk about the strategy for this. So graphing rational functions. The following strategy can be used to graph f of x equals p of x divided by q of x, where p and q are polynomial functions with no common factors. So that's going to be important that you always make sure that it is as simplified as possible first before you begin this step-by-step process. Okay, so the first thing that we're going to do is we are going to determine if f has symmetry. So just like we did when we were trying to graph a polynomial, we wanted to plug negative x into our function to determine if we have symmetry. So remember, that means if I plug negative x in and my function remains exactly the same, then we have y-axis symmetry. If I plug negative x in and every single sign changes and I get the opposite, then we have origin symmetry. If neither of those cases happen, then we have no symmetry at all. We will find the y-intercept, if there is one, by evaluating the function f of 0. Okay, so we'll plug 0 in for x, we'll get a value for y. There might be one, there might not be one. Then we'll find the x-intercept, if there is any, by solving p of x equals 0. So we'll set the numerator equal to 0 in order to find the x-intercept. Hopefully that makes sense, because if I have 0 in the numerator, 0 divided by anything is 0. So that's why we really just have to focus in the numerator. We can continue. Step 4 is finding any vertical asymptotes by solving the equation q of x equals 0. Okay, so remember, it's my denominator that I never want to be 0, so any values that turn it to 0 is a vertical asymptote. Remember, it should already be simplified, so we don't have to worry about looking for any holes or anything like that. We're going to find the horizontal asymptote, if there is one. And then we're going to plot at least one point between and beyond each of the x-intercepts and the vertical asymptote. Okay, we have to have more than just the few points that we have in the prior steps. So that's why at least one point between x-intercepts and on either sides of vertical asymptotes. Okay, obviously, once all of those steps are happening, that will help us graph the function. All right, let's take a look at this example and let's follow the procedure that we just talked about. So we are going to graph f of x equals 3x divided by x minus 2. So hopefully we notice that the numerator is a monomial and the denominator is a binomial, neither of which can be factored any further. So this is as simplified as possible. So that means that I can go ahead and I can start my step-by-step process. So remember, step number 1 is substituting in negative x to see if we have any symmetry. So anywhere that there's an x, I'm going to plug in negative x. So we'll have 3 times negative x, and that's over negative x minus 2. So that will give us a negative 3x on the top and a negative x minus 2 on the bottom. While the numerator changed signs, and then in the denominator the x did, notice that the 2 did not. Okay, so if I don't have every single sign change or every single sign stay the same, then in this case there is no symmetry. So then our second step is now we're going to find the y-intercept. And so to do that, we're going to substitute 0 in for x. So we'll have 3 times 0 divided by 0 minus 2. Well, the top will be 0, the bottom will be negative 2, but 0 divided by anything is 0. So 0, 0 is a point that we are going to be plotting. The third step is to determine the x-intercept. So remember, this was a y-intercept. So now I want to determine an x-intercept by taking the numerator, which is 3x, and setting that equal to 0. So solving for x, we'll just divide both sides by 3, and that will give me 0. So, just like in our y-intercept, our x-intercept will once again be 0, 0 as well. All right. Then I'm going to find step number 4, which is vertical asymptotes. So remember, that is us taking the denominator, setting it equal to 0, and solving. So x minus 2 equals 0 means that I'm adding 2 to both sides. So x equals 2 is a vertical asymptote. Step number 5 is figuring out horizontal asymptotes. So horizontal asymptote, remember, we're looking at the degree of both the top and the bottom of our function. So we've got degree 1 in the numerator, degree 1 in the denominator. So that means I want to take the lead coefficients and divide them. So there's a 3 in the top, there's a 1 in the bottom. This will be y equals, 3 divided by 1 is 3. So y equals 3. So let's maybe, before we start looking for extra points to plot, let's start maybe plotting what we know. So I know that 0, 0 is a point that is both an x-intercept and a y-intercept. I know that I'm going to have a vertical asymptote at x equals 2, so I need to have that drawn in. I'm going to have a horizontal asymptote at y equals 3, so I need to draw that in as well. All right, so obviously at this point, that's all I have in my graph, and that's not enough information to get me what my graph looks like, which is why step number 6 is let's start plotting points that are on either side of the x-intercept as well as the vertical asymptote. So notice that on either side of 0, we could go, obviously we could do positive 1 because that's also then to the left of the vertical asymptote. So I'm definitely going to want that one. So let's substitute 1 into our function. So we're going to have 3 times 1 over 1 minus 2. So we'll have 3 over negative 1. So it looks like one of our ordered pairs is at 1, negative 3. So let me plot that point. We can honestly pick any other point to the left of that 0, 0. So, I mean, we could do negative 1, negative 2, negative 3. It honestly doesn't matter. So I'm just going to pick, let's pick negative 4. If you want, you could pick the point closest to it. I'm going to just do negative 4. Because when I do negative 4, we'll have 3 times negative 4 over negative 4 minus 2. So it looks like we'll have negative 12 divided by negative 6, which will give me then positive 2. So we'll have the ordered pair negative 4, 2. So then I can connect those points. Notice that then there's going to be a curve to it. It's going to curve, and it's going to be getting closer and closer and closer to the vertical asymptote on the left. And then it's going to be curving, and it's going to be getting closer and closer to the horizontal asymptote below. Okay, so that's the one side. Now I need to do the right side of the vertical asymptote. Okay, so I am going to pick maybe a couple of points. Okay, picking one point isn't going to let me connect something. So maybe let's pick like, I don't know, 3 and 4. So let's do 3 first. So when I plug in 3, we'll have 3 times 3 over 3 minus 2. So 3 times 3 is 9 over 1. So that means that at the ordered pair 3, 9, we'll be able to plot that. Okay, and I'm going to pick one more point. So like I said, let's pick 4. So we'll have 3 times 4 over 4 minus 2. So we're going to have 12 over 2. So that means that at 4, we'll be at 6. So 4, 6. Okay, so then that means that those points are going to get connected. It's going to be getting closer and closer to each of those vertical and horizontal asymptotes as well. So there's a curve to that. And this would be my rational expression graph. Let's take a look at another one. So we've got f of x equals 2x squared divided by x squared minus 9. All right, so let's see if we can simplify this. I can definitely factor the denominator. So if I factor the denominator, it's going to turn into x minus 3 times x plus 3. So even though I can factor, it doesn't look like there's anything in the numerator that is going to reduce down the denominator. So I'm going to leave it in factored form, but that is as much as I can do. Okay, so then if we follow our steps, first step, once again, is I want to substitute in negative x to see if we have any symmetry. So we're going to do 2 times negative x squared. We can go back to the original before it was factored. We could do negative x quantity squared minus 9. So notice that when I square a negative, it's going to be positive. Same thing down here. When I square a negative, it's going to be positive. So notice that what I got was the exact same answer that what we started with. So when I substituted in negative x and I got the exact same function as f of x, that means that we do have symmetry. It's y-axis symmetry. And that's really going to help us then at the very end when we have to start plotting points, because we're just going to have a mirror image. So that means that I'll have to plot less points because then I can just reflect that over the y-axis. All right, moving on to the second step, we are going to find the y-intercept. And so to do that, we are going to substitute in 0 for x. So we'll have 2 times 0 divided by, that's squared, divided by 0 squared minus 9. Well, the numerator will turn into 0. The denominator will be negative 9. That will still get me 0. So it looks like my y-intercept is at 0, 0. So I can plot that point. If I then want to find an x-intercept, I have to set the numerator equal to 0. So 2x squared equals 0. I'll divide both sides by 2. I'll get x squared equals 0. When I take a square root, I'm still going to get 0. So once again, makes sense. 0, 0 is not only an x-intercept, but it's also a y-intercept. I'm then going to identify what my vertical asymptote is. Notice that in this case, I can refer to my factored denominator. I want to set each of those factors equal to 0. So x minus 3 has to equal 0, and x plus 3 has to equal 0. So it looks like I have 2 vertical asymptotes. I have a vertical asymptote at positive 3, so I can draw that in. And I have a vertical asymptote at negative 3, so I can draw that in as well. All right, our fifth step is identifying the horizontal asymptote. Notice that both degrees are the same. They are both degree 2. The lead coefficient is 2 and a 1, so it's going to be y equals 2 divided by 1, which is 2. So y equals 2 is the horizontal asymptote that I have to draw in. All right, so notice that this is once again why I need some extra points, because right now I only have 1 point in this whole entire what's supposed to be a graph. But like I said, the nice thing about having y-axis symmetry is I can really just focus either on the right side of that x-intercept or the left side, because then it's going to end up being a mirror image. So let's do maybe the right side. Okay, so let's maybe substitute. I want a couple of numbers in between, or like to the left and to the right of the x-intercept. So let's maybe do like, I don't know, we could do 2. So f of 2 is going to be 2 times 2 squared divided by 2 squared minus 9. So 2 squared is 4 times 2 is 8. 4 is in the denominator, minus 9 is going to be negative 5. So I'm going to then divide that. So roughly negative 1.6. Okay, so then at 2, I'm going to go down to negative 1.6. So then that means that at negative 2, I also get to go down to negative 1.6 because it's a mirror image. So notice that what I'm getting here in between those two vertical asymptotes, I am going to be getting basically a parabola looking shape because it's going to continue to go down and down and down. So that's what's happening in the middle of those two vertical asymptotes. So now let's look at what's happening then on the right side of the x equals 3 vertical asymptote. So let's substitute in 4. So we're going to have 2 times 4 being squared divided by 4 squared minus 9. So we'll have 4 squared is 16. 16 times 2 is going to be 32. 16 minus 9 is going to be, 7. So then if I divide this, that's going to be approximately 4.57. Okay, so at positive 4, I'm roughly around 4.5, a little bit more than that. So that's about right there. So once again, it's a mirror image. So that means at negative 4, I'm also at that 4.5. Okay, obviously I'm going to want another point or two. So let's, keep going. Let's maybe do 5. So that means we'll have 2 times 5 squared. And then in the denominator, we'll have 5 squared minus 9. Okay, so we'll have 5 squared is 25, and 25 times 2 is 50. In the denominator, we're going to have 25 minus 9, which is 16. So when I divide that, it's going to approximately, it'll give me 3.125. So at 5, I'm a little bit lower, so a little bit above 3. Oops. So notice that I could connect those points, and it's going to be getting closer and closer to each of those vertical asymptotes. So that means that at negative 5, we're going to be at 3.125. So then same idea, I'm going to connect those. It's going to be curving on either side, getting closer and closer to the vertical asymptotes. So there would be my graph. Okay, so that's us graphing rational functions.